In this video, I will explain how to use Boruvka's algorithm to find a minimum spanning tree in a graph. So let's start with a quick definition. A minimum spanning tree is a subset of edges in a connected weighted graph that connects all vertices with no cycles and has the minimum total edge weight. So one way to find a minimum spanning tree is to use something known as Boruvka's algorithm, which is a very simple algorithm. It's only 2 steps. The first step is for each vertex in the graph, select the edge with the smallest weight connected to that vertex. And then step 2 is if there's more than one component, i.e. a group of connected vertices, then connect the components using the edge with the smallest weight. So let's consider the following graph down here. It has 7 total vertices, and we can see that the vertices connected using edges that have weights with them. So let's see if we can use Boruvka's algorithm to find a minimum spanning tree for this graph. So as step 1 in the algorithm says, for each vertex in the graph, select the edge with the smallest weight connected to that vertex. So let's start with vertex A right here. So we'll just go in alphabetical order. What is the edge with the smallest weight connected to this vertex? Well, we can see there are 3 edges connected to this vertex. The one with the smallest weight is this one right here, which has a weight of 2. So we're going to select this edge as the first edge in our minimum spanning tree. So let's just go ahead and color that edge red. Then we'll move on to vertex B right here, and we'll repeat the process and we'll say, okay, let's pick the edge with the smallest weight. So we can see there are 1, 2, 3, 4 edges connected to vertex B. So there are 2 that have the smallest weight. This edge and this edge both have a weight of 2. So when this happens, you can pick either one. So let's go ahead and just pick this edge right here to add to the minimum spanning tree. All right, next we'll move on to vertex C right here. So what is the edge with the smallest weight connected to vertex C? Well, here's one with an edge of 2, and here's another one with an edge weight of 2 as well. So since we've already selected one of these 2, we're just going to keep this edge right here in the minimum spanning tree. So we don't need to select a new edge to connect. All right, now we'll move on to vertex D right here. So the edge with the smallest weight connected to vertex D would be this edge right here, which has a weight of 1. Then we'll move on to vertex E. The edge with the smallest weight connected to this vertex is also this edge right here with a weight of 1. So we'll just leave that. And then we'll move on to vertex F. So the edge with the smallest weight connected to this vertex would be this edge right here with a weight of 2. So we'll choose this edge. And then lastly, we'll move on to vertex G down here. And the edge with the smallest weight connected to this vertex would be this edge right here with a weight of 3. So we're done with step 1 in the algorithm. For each vertex, we selected the edge with the smallest weight connected to that vertex. Step 2 says if there's more than one component, which is just a group of connected vertices, then connect the components using the edge with the smallest weight. So we can see that after we completed step 1, we have 2 components here. So here's one group of connected vertices, and here's another group of connected vertices. What we want to do is connect these 2 components using the edge with the smallest weight. So we can see there's a few choices. We could use this edge right here to connect the 2 components, or this edge, or this edge, or this edge, or even this edge. So the one with the smallest weight would be this edge right here, which has a weight of 2. So if we choose this edge as the one to connect the components, then all of a sudden we'll see that all of the vertices are now connected. So this is our final minimum spanning tree. So just to make it a little more obvious, I'll draw it over here. So here is our minimum spanning tree, and we can find the weight of this minimum spanning tree by just adding up the weights of all of the edges in the tree. And when we do that, we'll find that the total weight is 12. So essentially, we just found a way to connect all of the vertices in the graph using no cycles and using the minimum possible edge weight.